Y'all didn't know there was such a thing.
Okay, so guys, today we're going to learn how to add and subtract. And you're going, I already know how to add and subtract, which is fabulous. So you already know how to do this. Okay? But today we're going to add and subtract rational expressions. So this is something you already know how to do. We're just going to use it in a slightly different context. Okay, so back in fourth grade, you learned how to add fractions with like denominators. So we would add fractions with like denominators. All right, so to do that, you might have a problem like this. 3/8 plus 2/8 make how many eighths? 5/8. All right? So when we were adding with like denominators, it's pretty easy. You just add the numerators, right? That's all there is to it. Okay? And then 5th grade got a little more challenging because we went from like denominators to learning how to add fractions with unlike denominators.
It's tricky.
Okay. So, but you mastered this before they let you leave elementary school. So it worked out all right. So you might have like 1/2 plus 2/3. So what did you guys have to do?
Find a common denominator.
You did. You had to find a common denominator. So what is the common denominator for 2 and 3? 6. Okay? So that's what we did. So when we have unlike denominators, we have to find a common denominator. All right. And in this case, it's just the product of the two. 2 and 3 is 6. So what we have to do to get a common denominator of 6 is we have to take this first fraction and multiply it by 3/3. Because 2 times 3 is 6. And we have to take the second fraction and multiply it by what? 2/2. So this gives us 6 as our denominators, check. And then our numerator becomes 3 plus 4. And 3 plus 4 is 7. All right, so you already have mastered the concept. Now we're going to do it in terms of rational expressions with variables. So we'll start off with very simple ones, and then we'll build up to more interesting ones. Some of you will choose to not. That is true. That's true. Some of you will choose to not. All right, but many of you will choose to do because you'd like to finish with credit. All right, so here we go. Numero uno example for what we're doing. All right, if you guys need to leave to have a discussion, you can go ahead and do that so that I can teach those that want to learn. All right, number 1, 5/6x minus 2/3. All right, first of all, it is not addition. So whenever we have something that's not addition, the first thing we do is we rewrite it as addition by changing the signs of everything in the numerator that follows. Well, lucky for us, there's only one thing, 2. So we change it to plus a negative. But if this were 2x minus 1, we would change the sign of everything in that numerator that follows. All right, so we don't really deal with subtraction at all because we eliminate it immediately. We rewrite it as adding the opposite.
Just like division.
Just like division. We don't really deal with division. We rewrite it as multiplying by the reciprocal. So really, all we have to learn is multiplying and adding, and we're good. Okay? So now we have to get a common denominator. So what's the smallest number that both 6 and 3 divide into? So it at least has to be 6, because they both have to go into it. What do you think?
3.
6 goes
6.
into 3.
6. It's 6. Because 6 divides into 6 and 3 divides into 6. So if we're looking for a common denominator and we have numbers, the common denominator at least has to be equal to the greatest number. A lot of times it's bigger, but this time it is the greatest number. All right, now this one has an x, but this one doesn't. So the common denominator has to have an x. Because each of these denominators, every factor in these has to be represented in that denominator. And it is. Every factor in either denominator is represented in the common denominator. All right, so this was already over 6x. So does it have to change at all? No, it stays 5. But the second expression was over 3. Now we need to make that turn into 6x. So what do we multiply 3 by?
2x.
2x. So this becomes 2x over 2x. So this numerator is now negative 4x. And now we have successfully subtracted these two fractions. That's it. Okay? Ready for example 2. Number 2. All right, so we have 2 over 5x minus 20 plus 7 over x minus 4. So this is just addition, so we do not have to change any signs. But we do have to find a common denominator. These are not like denominators, so we must find a common denominator. Now, this one is not in factored form. So when we have an expression that is not factored, the first thing we would do is factor it. So when you're looking at your denominators, you want to factor them so that it helps you find the common denominator. Okay, so if we look at this denominator, the two factors are 5 times x minus 4. If we look at this denominator, its only factor is x minus 4. So a common denominator has to represent both. So what would it be? 5 times x minus 4. You are right. Okay, so does the first numerator need to be multiplied times anything? No. Stays the same. Does the second numerator need to be multiplied by anything? Yes. What does it need to be multiplied by? 5. So this becomes 35. And so it finally simplifies to 37 over 5 times x minus 4. Okay, then I get a little more interesting. 3 over y plus 3 plus 2y over y squared plus 7y plus 12. We do need to factor. Now, does the denominator of the first expression factor? No. But the denominator of the second expression does factor. So go ahead and factor it. Okay, so did yours factor to y plus 3 times y plus 4? All right, what's the common denominator? Y plus 3 times y plus 4. All right, does the first expression need to be multiplied by anything? Yes, what is that? Y plus 4. So I get 3y plus 12. And then I add 2y to that because this numerator didn't need to be multiplied by anything. So it remains 2y. And then I just combine like terms. So it's 5y plus 12 over y plus 3 times y plus 4.
Bless you. I always sneeze. No one's phone's in the pouch.
Not a single phone is in the pouch? So I pretty much have to state it, huh?
You just snitch on yourself.
Or it doesn't happen. And he's not looking at his phone, he just noticed.
I'm just a good student and stuff, so.
That is true.
Oh, mine's right there. Right there, right there. Oh, you just snitched on yourself too. Gosh, I just want to squeeze your ears so hard. I just want to snitch on myself all the time.
Alright. Stop. No touch. Number 4. Alright, looks uglier. Actually easier. Why is this one easier?
All you do is try to throw
It already has a common denominator. Those are like denominators. So all we have to do is combine like terms. So 3x squared minus 2x squared is x squared.
Sorry, you're
Negative 4 and positive 4 cancels. Positive 2 and negative 3 makes minus 1. Now,
I'm defenseless.
we would be done, except, what does that numerator do?
cancel.
It will cancel after we factor. So sometimes when we get to this point, what it's simplified to will factor. Now, when I factor it, does it help me simplify the problem even more? Yes. Sometimes it doesn't. And so if it doesn't, no need to do it. But in this case it does, because the x minus 1's cancel. So a difference of squares always factors to the square root plus the square root minus the square root. So this simplifies to just x plus 1. Okay, 2 more, and then you just get to practice. Now, some of you did a great job practicing last night. Some of you tried real quick to finish between 8:32 and 8:35.
Ryan. No, Adam.
So,
Oh, not Ryan.
Just that for that counts.
It's been 3 hours.
all right, example 5. My denominators look very similar, but they're not the same. So I do not have like denominators, but it's really, really, really close.
Isn't it the same though?
So there are 2 approaches to this problem. The easiest one may not be intuitive for you, but I like it, and I'm going to show you. When I look at these 2 denominators, they're just opposite signs. Do you see that? So, if I multiply this one by negative 1 over negative 1, negative 1 divided by negative 1 is just 1. So I'm not changing the value of this expression at all. But I am forcing a common denominator, because multiplying by negative 1 just changes the signs. And isn't negative 2 plus x the same as x minus 2?
Oh yeah.
Yeah. You know what? I'm not even going to show you the other way, because that is the easiest way. And that's the way we're going to use.
Show us out of the way.
No.
Please.
No. Changed my mind. I'm not going to do it.
It might help
Okay.
me think better.
Wrong. So now they have the same denominator. So we just combine the numerators. And we're done. Whoop whoop. That whoop whoop thing went out of style like 8 years ago. I'm slow to catch on.
It's woo. Now.
I do that too.
You have to go. Woohoo!
I do it better than that.
Do it.
When you deserve it.
When Ryan gets an answer right.
All right. You ready for the last one? I think you can handle it. It's going to be no tears. Here it comes. 4x plus 1 over.
Don't pull away when you grab my ears. There you go. We don't have any room to write it.
All right. They are not the same denominator. So that means we have to factor, which is really good because we need practice. All right. So this has a leading coefficient of 2. So the only way to get 2 is 2 times 1. All right. What is the only way to get 3 with integers? Yes, 1 times 3. Now, what we have to do is play with it, though, because we want this product plus this product to equal 1. So we want a positive 3 and a negative 2. A positive 3 and a negative 2x makes what? Y'all remember factoring?
Makes X. You wrote 1, not 2.
When you multiply it across, it becomes a negative 2.
Okay, this becomes negative 2x
Right.
and positive 3x.
Right.
And when I add those,
Right,
Two,
what
and
you
she
just
writes
said.
one.
Right, come on.
all right,
Alright, how many other people were saying this?
okay, it's okay. All right, 2. Once again, the only way to get 2 is 2 times 1.
You gotta understand the mental thought process.
Okay, so we gotta think about what's going on here. This time I need to get a negative 1.
-3
Okay, so I need a 3 and a 2. So this makes 4x and 3x. Which one of these needs to be negative? To get a negative 1.
4.
The 4 needs to be negative, doesn't it? So the negative has to go there.
So you can factor out the two.
Yeah, these both have the 2x plus 3 in common, don't they? All right, so common denominator. Gotta have a bunch of stuff. They have the 2x plus 3 in common, so we only have to list it once. Then this one has an x minus 1. This one has an x minus 2. Common denominator is ugly. All right, what does this first one have to be multiplied by? What was it missing?
The negatives, the 6.
Negative 2.
X minus 2. That's what it was missing. What was the second one missing? X minus 1. Okay.
This is good to ugly very fast. Just
Yes.
not difficult, but ugly.
I agree. That's a really good way to describe it. All right, so we're going to distribute here. So we get 4x squared minus 8x. And then we distribute here. So we get plus x minus 2. All right. Now we're going to distribute over here. And this is a positive 7, right? So I don't have to change any signs. So I get plus 7x minus 7. Now I add like terms.
I literally can just do this in my head.
Alright, so we got 1 4x squared.
And basically right.
And then
Cancel out.
this makes, oh, that completely canceled out? Oh, how cool. And then we get minus 9.
Oh, yeah, that too.
You ever seen Rain Man?
Alright, so we have 4x squared minus 9. It's a difference of squares. It factors to the square root plus the square root times the square root minus the square root. Well, not yet. We're so close. He gave up.
Yeah,
But we were so close. And now what happens with the 2x plus 3? They cancel.
I say
I know where you're thinking of these copies.
Yeah.
Alright, so that's the hard kind, folks. That, I will admit. And it's what Thomas said just a minute ago. There's actually nothing terribly hard about it. It takes a little time, and it leaves you some, if you're not paying a good attention, or attention to detail, you could oopsie. Which is why, on your quiz, it's multiple choice. So hopefully, if you oopsie, you'll know before you turn the quiz in, because your answer would not have been there. Okay? So, alright, so yesterday, I gave you the wrong puzzle for yesterday. But guess what it's the right puzzle for? Today! You know what the great thing is,
I won't be here
Noah?
long.
You let me see how annoying I must be in the morning.
People at the end of the year, that's not gonna happen.
I thought you were just saying you're here tomorrow.